In this section, we're going to talk about thermal gradients and surface area in cooling. Now, as we mentioned at the start with Newton's law of cooling, thermal gradient is directly correlated to the total rate of heat transfer, so it's completely proportional. So, for example, skin temperature 36 Celsius in a room of 21 gives you a delta T of 15, whereas if you are in a hot environment at 36 Celsius, your delta T is 0, so you're not going to have any net passive heat loss. Now, there's some nuances to that. Of course, the outline example of when you would have heat gain from the environment, not from metabolic heat, would be situations like a sauna or hot tub where you have an exceedingly hot ambient environment relative to your skin temperature. So we're going to go into this in detail, but this is why training in hot and humid environments leads to rapid fatigue. When you're in a hot environment, it's not so much that the hot and humid environments burden the body with a lot of passive heat gain from the environment. More so, what happens is it eliminates or it dampens the body's ability to dissipate heat. So the body's still generating a lot of metabolic heat, and now the ability to balance the equation on the cooling side is really falls off a cliff and shuts down. And that's why when you have that low temperature gradient, you're unable to cool effectively. It's all heat load, and then the core temperature goes up. Now, the magnitude of T, of delta T, also determines the effectiveness of heat transfer. So we've seen this at different temperatures depending on what protocol or modality you are using, cold water immersion, for example, versus ice towels. Again, there's a lot of nuances based on surface area, fluid medium, duration, application, but thermal gradient is definitely something to keep in mind. Now, an important caveat, and we're going to discuss this in detail later in the course, is that colder is not always better for heat dissipation from the body, specifically when applying to the glabrer skin, so the palms of the hands, soles of the feet, upper face. They are very, very sensitive to temperature. They will vasoconstrict when the temperature is too cold. That'll reduce blood flow to those areas and therefore reduce the actual heat that's being presented to the interface, and there will be less total heat transfer. So when you get to certain areas, and we're going to talk about palm cooling extensively in this course, colder is not always better. In fact, you're better off to be at a more temperate. So it's a very fine line between what is the optimal thermal gradient as well as optimal blood flow so that there's actually heat being provided to that area for heat transfer to occur. Then adding on that, there's a thermal gradient, but there's also surface area. Generally speaking, the larger the surface area, the better. Now, not all areas, though, contribute equally. So there's different levels of efficiency. So surface area is also a little bit nuanced because in the palms of the hands, soles of the feet, and the upper face, the glabrer skin, the vasculature is much, much denser. So the total amount of blood flow through these portals and the total amount of heat transfer through these portals is actually significantly higher per square inch or per surface area than other parts of the body, which are more insulated. So again, surface area is not 100% directly correlated to efficiency of the cooling. There are a lot of physiological differences, and we're going to look into the anatomy further, particularly the glabrer skin with arteriovenous anastomoses, the dense capillary network. And even though it's just a small percentage of the total skin surface area, lots of research on the efficacy for core body cooling and performance enhancements. Finally, optimizing practical cooling. So just a few quick principles. You want to expose as much unclothed skin surface as possible. So generally speaking, while there are differences in efficiency, more surface area is better. Generally speaking, higher delta T is better. And then when you can, you want to target high flux zones, palms, soles, foreheads. Those, though, you got to be careful with not overcooling.